To find the exact area bounded by the curve, the line, and the y-axis, which happens to be R and is labeled R for you already. Okay. Now, because it says 2 marks here, right? By right, the finding of area is not exact. Okay, they don't need the exact area, but I added in the word exact. So I'm going to show you how to show it in exact form and how to use the calculator to find out the answer. So we know that if I go and generate the area under curve, and in this case, they are very nice already to already tell you the point of intersection. If not, you have to do simultaneous equation to find the point of intersection of the line and the curve. So I know that if I generate the area under curve, I'm going to get this part, right or not? Yeah. So to get R will just be, you need to find out the rectangle, which is this. Minus of the area under curve, which is the red one. A rectangle is base times height, root 3, times the height is here, 5. Minus area under curve from 0 to root 3, 2 over square root 4 minus x squared plus 3 dx. Okay, so because it's 2 marks, right, all you need to do is to key in the calculator. This, you should be able to get 1.3697 or approximately 1.37 square units. Okay, but if the question asks you to put it in exact form, then this is the way to do it. This would be 5 root 3. Okay, I'm going to use red, and the working will be over here. 5 root 3 minus, take out the 2, integrate 1 over square root, this is 2 square minus x square, plus 3 dx. Okay, with a definite integral of root 3 and 0. That will be 5 root 3 minus 2. Now when I want to integrate this, when you see square root, there's only 1. It's sine inverse. Just apply the sine inverse formula, x over 2, with the definite integrals, root 3 and 0, plus 3x, root 3 and 0 over here. So this will be 5 root 3 minus 2. Put in the definite integrals, sine inverse root 3 over 2 minus sine inverse 0. Okay, plus 3, take out, sub in the root 3, minus 0. Then I group all the root 3's together, this, okay, as well as 3 root 3, that will be 8 root 3 minus 2. Yeah, this, you need to know the special angle table. This will give you pi over 3. If you still don't know the special angle table very well, so all you need to do is to key this into your calculator, and when you inverse, you are getting an angle, so you divide the answer by pi, then you will get 1/3. Okay, and then this will be your answer, 8 root 3 minus 2 pi over 3 square units. Okay, if you're not sure of the special angle table, let me show you. Is that how to, firstly you have to know the numbers. Like when you sine inverse root 3 over 2 or root 2 over 2, the answer must be in terms of pi. Okay, it must be in terms of pi. And as a student, I didn't really memorize it. Okay, what I do is I will key into the calculator. So this is sine inverse square root 3, yeah, over 2. Okay, I press enter, I will get this. I divide the answer by pi. I will get 0.333, and at this point you should know that 0.333 is 1/3. If not, you press math, enter, enter, you will get 1/3, and this is how I get pi over 3. I'll key this into your calculator, you should get the same answer as 1.37. Okay, so for the next part, if we are going to do the volume generated, okay, hang on, let me paste it. Okay, so the question asks me to find the exact volume generated by R as it goes about the x-axis. Yeah, so x-axis is a little bit harder. You want to go about here, right? R goes about here. Again, you see, I need to use the cylinder. This is a cylinder because when I have this and it goes about the axis, this is the shape that is formed. Can see? That will be the center. Yeah, this is the cylinder. Okay, if not, you can just strictly, part 1, do integral from 0 to root 3. Okay, what is the y? Y equals to 5. 5 square. Okay, pi, because it's still pi y square dx. Yes? So if I generate the cylinder, the volume generated by the curve, this is the curve, the volume generated by the curve is this part as it goes around here. But I only want R, you see. So it should be minus, there's a pi over here, pi integral from 0 to root 3 minus 2 over square root 4 minus x squared plus 3 whole thing bracket square dx. Okay? So this is how you form your equation first. Then now the rest of it is purely integration. This is pretty simple. 25 pi. Take out the 5, then you're left with 1, right? Integrate 1, I will left with x with a root 3 and a 0. Minus, take out the 2 as well for the 1 over. Okay, this put in a big bracket. Maybe it's a little bit harder because there's a 3. Sorry, my mistake over here. Okay, what I need to do is to integral. You see there's a power 2, right? Use your a plus b expansion. A square plus 2ab plus b square, yeah, dx. Yeah, because it's pi y square. Remember to square the y. And anything power 2 you can expand. Okay, so this will be 25 pi. There will be a root 3 minus 0 inside, so I'll just keep it as root 3. Now this is the part that you can kind of like split. So take out the 4, integral root 3, 0, 1 over, I will always put it as 2 square already, minus x square. Dx plus integral, take out the constant, 2 times 2, 4, this is 12, 1 over square root 2 square minus x square, root 3 and a 0, dx plus 9x with a, I integrate already for this, okay? Yeah, on the inside. Brackets is so important. The reason why you were always careless is because you are not very careful with brackets. Okay, so this will be 25 root 3 pi. Keep it as that. Minus pi 4. How to integrate this? All you need to do is to look at your MF27. You have to identify the forms when it gives you in MF27 that is on top here. Okay, I'm just going to bring this down. Or 2 square minus x square, can you see? It is this one over here. So I'll just apply it inside. Yeah, 1 over 4 because the a, this is the a and this is the x. 1 over 4 ln 2 plus x over 2 minus x. Okay, keep it there with a definite integral, root 3, 0. Just apply it correctly. Okay, make sure you identify correctly. The other one would be 12 sine inverse x over 2 with, you can put this in, root 3, 0. And the other one, this will be 9 root 3. Okay, you just put it nicely over here. Or next one, sub in 25 root 3 pi minus pi. This and this will cancel. This will be ln 2 plus root 3 over 2 minus root 3, okay, plus 12 sine inverse root 3 over 2 minus sine inverse 0, which is going to be 0, okay, plus 9 root 3. Square bracket here, then you can work out your final answer. 25 root 3 pi minus pi ln 2 plus root 3 over 2 minus root 3 plus 12. This is pi over 3, so 12 pi over 3 plus, okay, there's a bracket here, 9 root 3. Final answer, 25 minus 9, that will be 16 root 3 pi minus pi ln 2 plus root 3 over 2 minus root 3 minus 4 pi square units cube. Okay, and this is how you leave the exact volume when it is generated about the x-axis. Okay, so anything complicated square, you still can open it up by just using normal expansion, and then you realize that after that you can use your formulas to do it. Okay, I'm going to talk about the generating with respect to y-axis. If I want to generate this with respect to y-axis, is pretty straightforward. It will just be the area under curve with respect to the y and going to this side. But before that, if I want to make area under curve with respect to y-axis, the first thing is I must find my limits, which is my y-intercept here. Okay, so when x equals to 0, my y is equals to 2 over square root 4 plus 3, and that will be 4. 2 over 2 is 1, 1 plus 3, so that will be 4. Then I need to make x squared the subject, not just x, if I can make x squared the subject, that would be great. Okay, so y equals to 2 over square root 4 minus x squared plus 3. Y minus 3 equals to 2 over square root 4 minus x squared. Kind of like bring this up and bring the square root up and bring the y minus 3 as a whole group down. That will be 4 minus x squared with this square root equals to 2 over y minus 3. And then I square on both sides. 4 minus x squared is equals to 4 over y minus 3 bracket square. Make x squared the subject. Don't need to make x the subject because you are going to integrate pi x squared. 4 minus 4 over y minus 3 squared. Okay, so this is your expression in terms of x squared. Now the volume generated is just straightforward integral from 4, because over here is 4, here is 5, 4 to 5, 4 minus 4 over y minus 3 bracket square dy. When I do dy, everything over here must be in terms of y, and since it's already x squared, I don't need to square it again. Yeah, so be careful. The integral of this is pretty straightforward. Maybe you can bring this up first. Y minus 3 to the power of negative 2 dy, and you're going to get 4y minus 4. This is just normal chain rule to the power of negative 1, add 1 to the power, divide by negative 1. Yeah, the coefficient of y is 1, so you can put the 1 down here, but don't have to put it doesn't matter. Okay, 5 and 4. So all you need to do is to make it nice first. 4y minus, or rather become plus, 4 over y minus 3, put the 5 and the 4 inside, and now just key into your calculator, and you should get the final answer, which is all in numbers. Or if you want to work it out, that will be 20 plus 4 over 2. See how I do? I sub in 5 first, minus 16 plus 4. Okay, and then the answer is just 2 square cube units cube. Yeah, because it's volume. So a few things to take note is, yes, when you do with respect to y, make sure you have the y-intercepts as your values, okay, or the limits when it is the y values, as well as make x squared the subject. And if an equation already has x squared, you don't need to find x and then after go and square it. It makes things hard for you, Just make x squared the subject, and then you can apply pi x squared dy, and then you will be able to get your answer.